So this next section says to multiply or divide. Again, we have to factor before we can cancel anything in the numerator or denominator. So I'm going to remind myself that I have to factor first before I can start just slashing something at the top and the bottom. And then in addition to that, if it's divide, there's one extra step. So the number 8 is a divide. So in order to change this division problem into a multiplication problem, the numerator and the denominator of the thing that you're dividing have to switch, or you multiply by the reciprocal. So this denominator is going to end up in the top, and this numerator is going to end up in the bottom. While I'm switching those, I'd also like to factor just to save myself a step here. So when I take a squared plus 3a plus 2 and put it in the top, I'm going to factor that into a and a plus 2 plus 1. Cool. On the first fraction, there is no division sign in front of it. Obviously, that wouldn't make much sense. So I'm just going to go ahead and keep that exactly the same. And I'm factoring it at the same time. So I'm looking for two numbers that multiply to a 6, a positive 6, and add to a negative 5. So this one's tricky because 2 times 3 seems like it adds to 5, and also 6 times 1 multiplies to 6, but it looks like it subtracts to 5. So in this case, because both signs have to be the same, and they both have to be negative in order to add to a negative, if you put negative signs on all of them, the only one that makes sense is the 2 and the 3. So a minus 2, a minus 3. Negative 2 plus negative 3 is negative 5. Negative 2 times negative 3 is a positive 6. So the 2 and the 3 work. The 6 and the 1 wouldn't because it would make negative 7, not negative 6. Negative 5. Okay, so the next one, I'm looking for two numbers that multiply to 3, add to negative 2, so that's 1 and 3. In order to add to a negative 2, the negative has to go on the 3, and the positive will go on the 1. That way it multiplies to a negative and also adds to a negative. Once everything's factored and flipped in the right order, then I can just take anything in the top with anything in the bottom that has a common factor and divide it out. So I see an a minus 3 and an a minus 3. Additionally, I see an a plus 1 with an a plus 1, one in the top, one in the bottom. There's nothing left that I can reduce, one in the top and one in the bottom. So everything else is going to be in my answer. A plus 2, a minus 2 on the top, and a minus 5 on the bottom. You're required to have the parentheses around the a plus 2 and a minus 2 on the top. You don't have to have them in the bottom, but I like to just keep it there just to remind myself that I can't go and cancel anything else. Now both 9 and 10 are multiply. So because they're multiply, we don't have to flip the second fraction. So I'm just going to go ahead and factor and reduce. Okay, so y squared minus 1, that's a difference of squares, y plus 1, y minus 1. The bottom, y plus 2, that doesn't even have a squared, so you don't have to worry about factoring that at all. Two numbers that multiply to 6 and add to 5. Now both of them are positive, that's what this positive sign says. And that means the signs are the same, and because they're adding to a positive, then they're both positive. So it looks like 2 and 3 again. And then the next one, I'm looking for two numbers that multiply to a negative 3 and add to a positive 2. So that's 3 and 1 with a positive being on the, from the 2 being on the larger value, which means y minus 1 on the second one there. So now I can divide anything in the top with anything in the bottom that looks exactly the same. I see a y plus 3. I see a y plus 2. What else? Oh, and a y minus 1. So all I'm left with is a y plus 1 in the numerator. Now, if you don't have anything left in the denominator, you're welcome just to put y plus 1 as an answer. But if the y plus 1 was in the denominator, you have to make sure you put the 1 over. But in this case, you don't have to write it. Okay, on to the next one. So again, it's a multiply, so I'm just going to go ahead and factor and cancel. So x minus 1, that doesn't cancel at all. So on the next one, that factors into x minus 3, x plus 2, two things that multiply to negative 6 and add to negative 1. The top, this one's a tricky one, 4x minus 12. It's supposed to be an easy one, just a GCF of 4, but a lot of people forget about GCFs because they've been doing so many other factoring, so don't forget that that's just an easy one. It trips people up sometimes. And then the denominator is a difference of squares, x plus 1, x minus 1. All right, what divides out? X minus 1 I see. I also see an x minus 3. And I think that's it. So I have a 4 left on top, an x plus 2, and an x plus 1 left on bottom. And that's how you finish up multiply or divide. Now adding and subtracting fractions is a little bit harder than multiplying and dividing fractions because you have to have a common denominator. So on number 11, notice on the bottom we have x plus 7 and then an x plus 7. Yay, this is really good news for us because that means the denominator is already common and it's going to stay there. And all I have to do is take both the numerators and then add or subtract whatever the sign in the middle says to do. So I'm just going to combine like terms. Negative 4x plus 6x is 2x. 2 plus 12 is 14 over x plus 7. And a lot of people would think you're done at this point. The reason you're not done is because of what we did on the first page. We have to simplify. So in this case, when you simplify, you have to factor. I can factor out a 2 GCF out of the numerator. Now that that 2 is being multiplied by the parentheses x plus 7, the opposite of multiply is divide, and these two divide out nicely, and your final answer is just 2. All right, so that one was a nice example because we had a common denominator already. Now the next two don't have common denominators, so you have to force the common denominator. So on number 12 we have x plus 4 and x plus 6 in the denominators. So my LCD is going to be simply x plus 4 times x plus 6. You have to have one of each. Okay, so on the first fraction I have an x plus 4, but I need both an x plus 4 and an x plus 6. What factor am I missing? Well, I'm missing an x plus 6 factor. If you multiply it to the bottom, then you have to also multiply it to the top. Now, I highly recommend not distributing this right now, and I'll tell you why in a moment, okay? On the next one, I have an x plus 6, but I need both an x plus 4 and an x plus 6. So the factor that I'm missing is x plus 4. If you multiply it to the bottom, then you have to also then multiply it to the top. Again, I said don't distribute this out on this step. Wait until the following step. So just go ahead and write 5 times x plus 6 minus 3 times x plus 4 because, now we successfully got a common denominator, which was the whole point, right? But the reason why I asked you not to is because to distribute into this next step is because when I distribute here I get 5x plus 30 and you're like, that's what I would have got. I didn't have to write it out. But here's the big mistake. This minus, which is attached to the 3, needs to distribute to both. So when you distribute, you get negative 3x minus 12. If you were to try to distribute on the first step and try to get 3x plus 12 and then slap the negative on, what you would do is you would probably only put the negative on the 3 and not the negative on the 12, and then you'd get the whole rest of the problem wrong. That is why I suggest that you write out what you're going to distribute before you actually distribute, and don't try to do that step in your head. Now that I got a common denominator, my denominator stays the same, x plus 4, x plus 6. And then I can add or subtract my numerators. So I have 5x minus 3x, that's 2x. 30 minus 12, that is 18. Okay, so at this point I need to factor. So I can factor out a 2 out of the numerator. The denominator, fortunately, is already factored. Nothing can divide here, so this is the final answer. Now, because nothing could divide here, the previous answer would have also been acceptable. They're both equivalent, and one's not more simple than the other, so either answer will work. But if you forget to try to factor, then you might get the problem wrong because it might have reduced and you didn't try. Okay, so make sure you try to factor, but in this case, if you accidentally didn't try, well, lucky you. Okay. All right, so the next problem, I need a common denominator. I have a plus 2 times a minus 1 for the first denominator. In the second denominator, I have a minus 3 times a plus 2. Now, the reason why I'm breaking those up right now is because I don't want to just take the two denominators, because that's going to be really, really huge. Notice each of the two denominators have a factor of a plus 2 in them. So when I find my LCD, I'm only going to use a plus 2 once. So on the first fraction, I need an a plus 2 and an a minus 1. So then the least common denominator gets those. Now on the second fraction, I need an a minus 3 and an a plus 2. Well, because I already have an a plus 2, I'm not going to rewrite that. All I'm going to do is add the next factor that I also need. So my least common denominator is going to be a plus 2, a minus 3, and a minus 1. And it doesn't really matter what order you have those in, just as long as you have all of them. Okay, on the first fraction, I have a plus 2 and a minus 1. The factor that I'm missing, that I really want, is a minus 3. If you multiply it to the bottom, you have to then multiply it to the top. Don't try to distribute on this step, we'll do it on the next. On the second fraction in the denominator, the factor that I'm missing is a minus 1. If you multiply it to the bottom, then you also then have to multiply it to the top. At this point, we're just going to distribute and combine like terms in the numerator, so that's negative 3a plus 9 plus 5a minus 5. The LCD, once you've gotten the LCD, it basically just stays the same unless it reduces at the very last step. Okay, in the numerator, I can add my a's. I get 2a, negative 5 plus 9, that's a positive 4. So I have 2a plus 4. And 2a plus 4, that factors. Remember, the last step you always have to try to factor and see if it reduces. Ah, look, it does reduce. A plus 2 is common in the numerator and the denominator. So my final answer is 2 over a minus 3, a minus 1, in either order.